Hello everyone, hope you are doing well. I'm going to present you the result of my work in enterprise integration patterns fields in our Siglis Masters. I chose to present the correlation identifier patterns and I'm Jeanpaul Tossou. This presentation will go through the following steps. In the introductions, we will talk about the context of use of the correlation identifier and of course the problem that it solves. Then, it will be the specification of its design, and following, I'm going to demonstrate the implementations of correlation ID I made for this course. And obviously, it will be the conclusion with some recommendation to go further in this pattern's implementation. Integration patterns are a set of best practice used in enterprise to enable better data exchange between information systems. The ones I'm talking about you today is called correlation identifier. It is his original name, but often it's also called TID. Correlation identifier can be used in combination with other patterns which are in the messaging subgroup patterns, and it's used most often with the request reply patterns and simpler answer equations. How does a requester that received a reply know which request this is for? The request reply pattern's goals is to permit data exchange between two systems. The first one, which is called requester, and the second one, which obviously is called replier. The first asks for informations, and the second one, after processing, return data or another information is in channels. But it's often happens that the requester makes several requests to other systems, and the replies are not always in the same order as their dispatch. So, when data is received, it's necessary to be able to associate the responses to requests in order to keep the coherence in the processing. And this is what allows correlation identifier. Correlation identifier, what is it exactly? Is a unique identifier and a way to track any request in distributed system and can help to monitor provision issue. To implement a correlation identifier pattern, we need to have 6 parts. The first one, requester, which is schematicized here as a client. The replier, which is here as server. The request, which is the message which will be sent to a server. The reply here, which is coming from the server, and the ID. We can see in this example that the ID is represented with ABC, and the correlation ID, which is the same ID with the request ID in this example, is also ABC. So when the client receives the reply, he can match the request with the request with the reply. Is what we summarize here. When we send 3 messages with ID, and in the response we got the ID in this order. So here the requester make a match between the response and the message and know what process it need to do on them. In my implementations, I use the example of a bank systems. During a cash withdrawal, the subsystem needs to know the balance of the account to know if the withdrawal can be made or not. The balance check systems part is done by another subsystems here, which take care of knowing the actual balance of the account, since several options like online purchases, cash withdrawal, and transfers can be done simultaneously. So in my implementation, I use RabbitMQ, which is well explained in the document provided with this presentation. We have many ATM which send with withdrawal requests to the cash withdrawal systems, and the withdrawal subsystems send on request to the amount check system to know if the amount the user asks for, it can be done. So the amount check system process with the database and check if the user have this amount and responds to the cash withdrawal. And then when this system have the response, he make a correlation with response in the message and know what response to return to and to what ATM. So let's go to the implementations here. We have account. This is our structure. We have account class represent an account. It's just a POJO. POJO is plain old Java object which implements serializable, as we can see here. And serializable permits us to send that this object in a flow, in network flow. We have on user, we represent the account with username and IBAN, the bank name, and the amount which the user want to withdraw. It's a simple POJO with setters and getters, and you have two methods here to transform the object in string and the inverse. Withdrawal class here represents the withdrawal subsystem as in the previous schema. It's a simpler. Here we initiate a connection and a channel and set it to localhost with default RabbitMQ credentials. And here we create the correlation idea channel. We create the correlation idea and pass it to the channel as properties. We initiate a basic properties here, which is a class provided by RabbitMQ, and we provide here the correlation idea with the string that we generate with this class provided by Java. It ensures that our random unique ID will be unique. After we pass that unique ID and we publish, as we need the response the response before continued treatment, we use a blocking queue. We initiate a blocking queue and pass the channel to that queue. Okay. And the last class is the amount checker systems. is the amount checker class represent this system here, and as is same like withdrawal systems, we initiate connection and channel here with localhost default credential, and we are waiting for request when we launch the class. When he received when it received a request, he changed the request in account here. When we get the message and we transform the message in account, then check if the withdrawal can be made. With this method, we are verifying if the account, well, we use a list of account here as a database, and we with a for each, we check if this account exists in our systems, checking their IBANs, and if so, we return a positive value, else it will be return a negative value. So here, when we check for a response, we initialize a channel with the correlation ID we get from the request, and we pass here as a basic channel to reply to the request, and is what we are doing here. And we have a last class which is a simple executor. In it we initialize we initialize 6 examples, and that this simulates the withdrawal system have 6 processes in the same times. And in the we have a method to show that to show if the withdrawal can be possible or not according to the response we get from the withdrawal systems. Okay, so to execute it, we need to execute before. I need to close my previous executions and made a new one. Stop. We need to have the amount checker systems running before, so we do that with a run. Here it's with this message awaiting for a client request, so the system is running, and so we run this executor, which will perform the simulation of 6 say withdraw at same times. So here is executing, and we can see that the withdrawal for the first account is possible, not for the second one, and possible for the others. So, and we can see the correlation idea for Jeanpaul Tossou, which begin with 1 GBEA here, and on the withdrawal systems, the check account system, you can see that is the same idea. Okay, so we arrive to map our request to our reply. Okay, this is the end of my demonstrations. Let's go to here, and I can show you the RabbitMQ console, and we can see here that we have the connection here, and we have all exchange all queues, and them exchange we make. Basic correlation queue have true. I execute my file before, and this is one we execute now. Okay, Thank you for watching. Correlation idea is useful for microservice logging applications, and we can know which request return some reply and what process was done on every. We can do that with save classic without a pattern, but we will need in this example to divide our process into a, a, a previous one, which is check for withdrawal, and after that we need to process to check for the balance before, and after that we need to process to the withdrawal. But here we avoid to divide the process into process, and that's permit us to avoid occupying the information systems. So, and it not need many development code, but something as for recommendations, we need to ensure that the generated identifiers provided are truly unique, because if we have in our systems to identify that is same is a really problems to coherent processing. Thank you for watching.